This is the brief on tensor contractions. So we're diving into this really powerful mathematical tool that helps us simplify complex tensors. You know, these things that track multiple directions at once, like stress or strain. Tensor contraction is basically our shortcut to make sense of it all. Okay, let's get into the key takeaways. First, just think of contraction as a simplifying operation. It takes a tensor and reduces its complexity, what we call its rank, by exactly 2. Every time you apply it, you're collapsing a complex structure into something fundamentally simpler. It's a way to cut through the noise. Second, how does it actually work mathematically? Well, it involves pairing up very specific components within the tensor, a vector part and a dual vector part. And when they're paired up, they essentially cancel each other out, collapsing two directional measurements into a single value. That's precisely why the ranks drops by 2. And finally, the really big idea here is something called invariance. See, the individual numbers in a tensor might change depending on your coordinate system, like how you're looking at it, but the final result of the contraction, that number, which we often call the trace, it stays exactly the same, no matter what. This proves it's a core, fundamental property of the system itself. So tensor contraction is the essential, unchanging operation we need to simplify and truly understand the intrinsic properties of mixed tensors.